Welcome to Section 1D. Roman numeral 1 is analyzing arguments. We have two different arguments, inductive and deductive. An inductive argument is where a general conclusion comes from very specific premises. A deductive argument is a very specific conclusion from general premises. Our first example is birds fly but come down, people jump into the air and fall back down, rocks thrown into the air come back down, balls thrown into the air, come back down. The conclusion? What goes up must come down. So all of my premises are very specific examples. Birds are flying, people are flying, rocks and balls. These are very specific premises, and then my general conclusion is what goes up must come down. This is an inductive argument. And again, I'm going to show you that I would like these highlighted, your answers, in some way or another. So I'm going to make mine red and bold, maybe even change the font or the size so that it stands out. The next example, all politicians are married. Senator Harris is a politician. Conclusion, Senator Harris is married. Let's look at the specific versus general for my premises. All politicians. Right there, that automatically says general. And then we get a little bit more specific about Senator Harris being a politician. And then we come to a very specific conclusion. Senator Harris is married. This right here is deductive. And again, I'm going to, actually, let's just do a format paint. Same as this, format painter. There's my answer. When I'm evaluating in an inductive argument, I look at the strength of the premises. Does it make a compelling case, or are all of my very specific premises not supporting the conclusion? I can only use my own personal judgment when I'm evaluating the inductive argument, and these can't be proven to be true. So here's my next example. Here's a movie, and my premises are that in this movie, we've hired very big stars for all of the lead roles in the movie. The next premise is I have a great advertising campaign. Another premise, it's a sequel to a last hit movie. Conclusion, the film will be a hit. So let's talk about the general versus specific. Here I have big stars, very specific leading roles for the movie. The advertising campaign, it's a sequel to the last hit movie, therefore the film will be a hit. Now I can only use my own personal judgment and evaluate the strength of this. I know I've seen movies where there were big hired stars, but the film ended up being a flop. Also, I have seen a lot of sequels where the original was much better and the sequel was also a flop. So my conclusion with my own personal judgment is that this is a weak inductive argument. And I'm going to put inductive on there because these are very specific premises to a general conclusion. The specifics being the stars, the advertising, the sequel, and the conclusion is this general statement that this film will be a big hit. And again, I'm going to highlight some way for that to be the answer. In this case, I'm just going to use the highlighter. Now moving on to the second example, earthquake. The premise is the San Andreas Fault has a major earthquake with at least once every 100 years. The conclusion, we should expect another earthquake during the next 100 years. So the premise is that I have this earthquake, and it is backed by historical documentation that happens on the San Andreas Fault. Then the conclusion is, for the next 100 years, watch out, something's going to happen. So I have a very specific and proven premise, and the conclusion is a very general, in the next 100 years, we're going to have something. So this one is also inductive, and because it is backed by historical documentation, I am going to say the strength of this argument is strong, and it is an inductive argument because I have a specific premises and a strong conclusion, and highlight my answer. Okay, moving on to evaluating deductive arguments. Now remember, these are two different arguments and they're going to be evaluated differently. Inductive, you can only use your own personal judgment to decide the strength of the argument. So now going on to deductive arguments, a deductive argument needs two different things, validity, and then once you establish validity, soundness. Validity is the conclusion follows necessarily from the premises. So I'm leading us down to the conclusion. And soundness is if it is valid and the premises are true, then it is a sound argument. An argument can be valid even if the conclusion is false, meaning that your argument is leading you to the conclusion even though the premises aren't true and the conclusion is false. Let's go to our first example. Our first premise is all politicians are married. The second, Senator Harris is a politician. So our conclusion is Senator Harris is married. Now let's go back and talk about general versus specific. My premise here is all politicians. That's a broad statement. So I already know that I have a very general premise. And if I look at the conclusion, it leads me down to Senator Harris is married. I like to do a visual here to show between inductive and deductive. A deductive argument, I like to paint a mental picture so that I can see which is which. And you've all seen either somebody, an older neighbor, or maybe even on TV, and he kind of talks with a little bit of spittle, and he's very decisive, and he's using his hands to gesture, and he has his hands up about shoulder width apart, and he brings them down, maybe a little spittle coming on the way, and he says, I deduce. And so he brings his hands together, forming a V, using his hand gestures. Now that you have this very specific image in your mind, this is what I like to visualize when I think of a deductive argument. This older gentleman, maybe a little greasy hair, and he deduces. So hands shoulder width apart, bringing them down into a V form, and he's saying, I deduce. So what this does is it goes from a general premise to a very specific conclusion, and it helps, especially with you tactile learners, and it helps us to see visually and even feel. So if you're not doing the V with me, that's fine. You're probably in public. If not, go ahead and try so that it makes that connection. So here I'm going to go from all politicians. So my hands are shoulder width apart. Senator Harris is a politician. I'm getting a little more narrow. And then Senator Harris is married. There is the point of my V, and I have led us to the conclusion. So it's showing general to specific. It's also showing as I'm going down that I'm leading to the conclusion. And if that conclusion comes from the premises and it's forming this V, it's also valid, which happens to be starting with the letter V, which is our little help. So all politicians, Senator Harris is married. So I do have this following of the premises, so it's deductive and it's valid. So let's talk about the soundness. Are all politicians married? Not necessarily. Therefore, it is not sound. A soundness means that all the premises are true. So here we go. An argument can be valid even if the conclusion is false. So even though I'm not coming, the soundness is not there. Roman numeral 2, testing validity. Which argument do we need to test validity on? Is that inductive or deductive? Well, validity has that V, so it's leading us to the conclusion that is deductive. And remember, inductive arguments, the only thing you can think of is your personal judgment. Consider the strength of the argument. So when I'm testing a validity, I I'm doing this for deductive arguments. So let's go back to the Senator Harris example. Our first premise is all politicians are married. The next is Senator Harris is a politician. And the conclusion is Senator Harris is married. So the way I'm going to do this is creating a Venn diagram. Now I have this one here. I'm going to go back just as a quick refresher about creating Venn diagrams. You go into Smart Art, go to Relationship, scroll down, and here's our Venn diagrams. So I'm going to go ahead and do this one. They call it a stacked, but in our book it is a subset. Okay, I only need 2 of these because I'm talking about married people and Senator Harris. So the first one is all politicians are married. So I know that the politician set is going to be within the married set. So I'm going to write married people. Within that, we set all of those politicians are in that married set. So we put politicians. And that's needing an I. Politicians. I'm going to make that a little smaller. Now, the conclusion, Senator Harris is married. This is where I put an X. Where would Senator Harris be? Well, the second one tells us Senator Harris is a politician. So Senator Harris is definitively in the politician circle. So is my conclusion Senator Harris is married? Well, if my X is within the politician circle, it's also within the married circle. So yes, Senator Harris is indeed married according to this argument. So here's our answer. X is within that politician circle. It does support the argument, and therefore it is valid. If during my process of finding where the X goes, maybe the X with what the argument states is somewhere out here, or maybe even on a line somewhere, then I can't say that it's valid. Let's go ahead and get rid of this one. Okay, the next one, I'm not going to show you the Venn diagram yet. All fish live in the water. Whales aren't fish, so whales don't live in the water. So the first premise is all fish live in the water. Is this going to be an overlapping, disjoint, or subset? An overlapping would say some, disjoint would be none or no, and inside a subset would be all. So all fish live in the water. So all of the fish need to be within the water subset, or the water set. So my Venn diagram will be all animals that live in the water, and within that are fish. Whales don't live in the water, or whales aren't fish. So I am definitively saying that whales are not in the fish circle. So here's my X. Whales are not in the fish circle. So the only thing I can say is, well, maybe my X is within the water. Maybe it's out of the water, but it does not definitively tell us where it should be. It just tells me that I'm not in the fish circle. So it can either be inside things that live in the water or outside things that live in the water. Whales don't live in the water? Not necessarily. It did not lead me to the conclusion, or to the conclusion. The whales may or may not live in the water. This is not valid. It didn't lead me to the conclusion. So I don't even need to test for soundness. But remember, soundness is testing whether the premises are true. Let's move on to the next one. And I'm not going to show you the answer of the Venn diagram yet. All, remember what all was? That's a subset. No means disjoint, where they don't overlap at all. Overlapping means that some of them are in both categories. In this statement, all 20th century US presidents are men. John Kennedy was a man. Conclusion, John Kennedy was a 20th century president. Okay, so I have all 20th century presidents are men. So all of those must be in the men set. So the bigger of the two is men. Then within that is all of the 20th century presidents. Now we need to talk about John Kennedy. John Kennedy was a man. So I know that I'm going to put an X somewhere in the man circle. But it didn't tell me where in the man circle. I'm not going to go outside of it, but it has to be within it. So does that definitively lead us to the conclusion that John Kennedy was a 20th century president? Well, I know it's in the man circle, but there are other men within the circle, not just US presidents. So here's my larger circle where I have US presidents are men. John Kennedy was a man, so I know he's somewhere in this circle. Did I definitively put him in this 20th century US presidents? No, my argument did not say he was in that circle. It just says he's a man. So he's in the men's circle somewhere. John Kennedy was a 20th century president. Yeah, that's true. But I didn't lead us to that in my argument. So my argument is not valid, even though it is sound. It didn't lead me to the conclusion. All right, let's move on to Roman numeral 3. Conditional deductive arguments. Remember what a conditional was? That was in the last section, 1C. Conditional is if and then. So conditional deductive is going to be an if and then within a deductive argument. Remember deductive? I'm going from general, put your hands shoulder width apart, and I'm leading to a conclusion. Okay, my first premise. If a person lives in Chicago, they love windy days. Next premise, Carlos lives in Chicago. Conclusion, Carlos loves windy days. So, am I leading us there? Did I take us from Chicago? Carlos living in Chicago, does he definitively love windy days? Let's go to the top. If a person lives in Chicago, then they love windy days. So that means every person that lives in Chicago loves windy days. If Carlos then is living in Chicago, the conclusion is yes, he loves windy days. This is a valid statement. So I can go ahead and make a Venn diagram of that, or I can use the following chart that will be provided in your book because you've done your reading before this section. You'll also need this chart for your homework supplement. All right, so we have 4 different options for our deductive argument. The first one is called affirming the hypothesis. If P, then Q. This is the hypothesis from the conditional statement. So I have a premise. Here's the hypothesis. The next premise then affirms that hypothesis that yes, indeed, P is true. Oh, I see a typo. That means that Q is also true, the conclusion. This is a valid statement. In fact, this is the same example of what we saw up here about Carlos in Chicago. If P, or the person living in Chicago, loves windy days, the next premise, Carlos lives in Chicago. So I have affirmed the premise, or the hypothesis from the first premise. And the conclusion is Carlos loves windy days. That's the conclusion, or Q. It is true. Therefore, it's valid. So I can go ahead and use this right here to state that it's valid, or I can go ahead and make my Venn diagram, which we did previously. The next one is called affirming the conclusion. So I take my conditional statement. If the hypothesis is P, then the conclusion is Q, and I'm affirming the conclusion in the next premise that Q indeed is true. And the conclusion will be that P is true. Is this a valid statement? No, it didn't lead us to the conclusion. Denying the hypothesis. The first premise is our conditional statement. If, with our hypothesis P, then Q. So I deny the hypothesis. P is not true, so the conclusion is not true. This one is an invalid statement. And the last one is denying the conclusion. So my premise is if P, then Q. The conditional statement, if, with the hypothesis, then conclusion. These kind of get confusing because a conditional statement has hypothesis and conclusion, or you can think of it as the antecedent and the consequent. And the argument itself, remember our V, starting at the shoulders and coming down, the argument also has a conclusion. So there are 2 different types of conclusions here. So this first denying the conclusion is talking about the conditional statement. The next, so the premise Q is not true. I'm denying the conditional conclusion, and the argument's conclusion comes to P is not true. This is a valid statement or a valid argument. Okay, let's try the next one, B, affirming the hypothesis. Affirming the hypothesis is a valid argument. This is our example of Carlos and windy days. So we have two ways of proving that it's valid. We can use our chart. You can find it in your book or on here, or you can create your own Venn diagram. So Carlos, that's affirming the hypothesis. So we have all people who love windy days, because there are more people than those that live in Chicago. Then all of the Chicago people must be in the circle of people who love windy days, because we stated if a person lives in Chicago, then they love windy days. So all those people need to be in the loving windy day set. And we stated Carlos lives in Chicago, so our X represents Carlos. We definitively put him in the circle of people who live in Chicago, which means he's also in the subset of people who love windy days. Does that support the conclusion of the argument that yes, indeed, Carlos loves windy days? Yeah, we have two ways of stating it. And he's definitively in there, so yes, it's a valid statement. Or you can just use your chart and say, yes, this is valid. Okay, let's move on to another one, affirming the conclusion. So my first premise, if an employee is regularly late, he or she will be fired. Next premise, Sharon was fired. Conclusion, Sharon was regularly late. Now remember, this is leading with a deductive argument from general to specific. So I go from a general employee, so all the employees, down to Sharon, and then Sharon was regularly late. That is a very specific conclusion for the argument. Now let's talk about the first premise. If an employee is regularly late, he or she will be fired. Is that the only way a person can be fired? No, there's other reasons. So the regularly late set will be within the fired set, because there are other reasons that somebody can be fired. But every time somebody's late, they will be fired. So I have a subset here of fired employees on the outside and regularly late on the inside. Now we state Sharon was fired. And the conclusion, Sharon was regularly late. Did we put her within that regularly late spot, that set? No, we only put her in the fired. She can be anywhere in that fired set. She can be in here, or she could be in here, but I did not definitively put her with my argument into the regularly late set. So, is this valid? No, affirming the conclusion is not a valid statement or argument, and we just proved it by using our Venn diagram, our visual. Let's try the next one, denying the hypothesis. If you like the book, then you'll love the movie. You did not like the book. Conclusion, you will not love the movie. Now, again, you can go up and use your chart, but we're going to verify that this is indeed an invalid argument. So, if you love the book, then you'll love the movie. So that means all of the book lovers, if you love the book, then you'll love the movie. But it doesn't necessarily mean that all the people who love the movie liked the book. So the movie is the larger of the two sets, and liking the book is in the middle. So people who loved the movie, outside, but if you loved the book, it's on the inside, because all the book lovers loved the movie. Denying the hypothesis, you did not like the book. The conclusion of the argument is you will not love the movie. Did I definitively get us there? Remember the V, starting at your shoulders, moving down? Did I lead us to that point in the V? So you did not like the book. That means I am not in the book circle, but it doesn't tell me which circle I'm in. It just told me which circle I'm not in. It's in the not like, or it's not in the liked the book. So I could be in the loved the movie, but I could be outside of the loved movie. I don't know. It doesn't definitively lead us there, which means it's an invalid argument. And the last one, denying the conclusion. A narcotic is habit forming. The next premise, heroin is not habit forming. So the conclusion, heroin is not a narcotic. So am I leading us there from the shoulder width V down to the narrow point? Okay, so if a drug is habit forming, then it is narcotic. Notice this isn't in the standard form of what a conditional statement is. So I have to think a little bit more about either rewriting it or putting it in the subset in my mind. So if a drug is habit forming, it is a narcotic. So I have habit forming drugs, and the narcotics are within there because all narcotics are habit forming. Okay, my premise, the next one is heroin is not in the habit forming circle. So if it is not within that habit forming circle, I can go outside of that. Therefore, the conclusion of the argument, heroin is not a narcotic. So my argument definitively put heroin outside of the habit forming drugs, which means it can't even be anywhere near the narcotic circle. Yeah, this is a valid argument. It stated that narcotic is not habit forming, and it led us definitively to the conclusion that heroin is not a narcotic. It is valid. Now that we know that it's valid, is it sound? This is not a sound argument. Heroin is definitely a narcotic, and this is a false or not sound argument. But it was valid because we led us to the conclusion. Kind of confusing, I know. Politicians use this stuff all the time because they can lead you to the conclusion, but it doesn't necessarily mean that they're telling the truth. Let's go to the next one, deductive chain of conditionals. So I have a premise, conclusion, and I'm using several conditional statements. The first one is if P then Q. The second, if Q then R. Conclusion, I have made a chain from P to Q to R, so the conclusion is if P then R. So our first one, if Maria is elected to the school board, then she will raise academic standards. The premise, I take the conclusion from the previous conditional statement. If the standards are raised, and that becomes my premise, or my hypothesis, and the conclusion for this one is my children will benefit. So if I eliminate the inside, I go straight from the first to the last. If Maria is elected, my children will benefit. This is a valid argument because it led me from one to the next, my little chain, P, Q, and R. Maria, standards, children. Let's try the next one. If you shop, then I make dinner. Next premise, if you take out the trash, then I make dinner. Conclusion, therefore, if you shop, you should take out the trash. Well, this might work in some households, however, it was not a valid argument. Let's go to this. If you shop, so shopping is P. Let's come over here and even just make our little diagram. So this is P, and making dinner will be Q. If P, then Q. Therefore, if you take out the trash, that's a new premise. So let's call that one R. Then I make dinner. Dinner, we already stated, was the Q. Therefore, if you shop, shopping was P, then you should take out the trash, which is R. Did that lead me from one to the other? I went from P to Q, R to Q, therefore P to R? No. This is an invalid statement. The chain of conditionals needs to link together. All right, moving on to Roman numeral 5, induction and deduction in math. So here I have a chain, or a set of premises. I have A times B equals B times A. 3 times 4 equals 4 times 3, which are true so far. And 1/2 times 3/14 equals 3/14 times 1/2, also true. 0.3 times -2 equals -2 times 0.3. Also true. So what I've shown is that with variables at the top, a and b, whole numbers, 3 and 4, fractions, 1/2 and 3/14, decimals and even negatives in the last premise, all of these are very specific examples for the commutative property, not commutative, there's no n, commutative property of math. This is a very strong inductive argument. In fact, it's so strong that it's called the commutative property, meaning that I have lots and lots of very specific examples where it works. It is not proven, but probably true, and in this statement it is. It's called the commutative property. There's not an example that will go opposite of this where it doesn't equal. Here's our next one. So here's my several statements of premises. A over B equals A plus C over B plus C. So I have 1/2 equals 1 on the top plus 0 over 2 plus 0. Does that equal? Yeah, it does. Let's try the next one. 1 over 2, or 1/2, does not equal when I add 1 to the top and the bottom. 1 plus 1 and 2 plus 1 gives me 2/3. This is not true. So I have my general conclusion from the inductive argument, but no, it doesn't work. Adding numbers to a fraction on the top and bottom doesn't equal. All right, we are all done with section 1D. I hope you meet up with me in the next section.